and welcome, and in this video we're going to be talking about operations with polynomials. But we're going to be focusing on adding, subtracting, and multiplying polynomials. Division is an entirely different animal on its own, and we've actually already covered these three, so this should be a quick refresher video. So if we had a problem similar to this one, where we had 2 plus 3x cubed minus x squared, so we have one polynomial there, plus 2x cubed minus 4 plus 7x squared. If we wanted to add these, all we're doing is combining like terms. And if you really wanted to, whenever you're adding, you can actually get rid of these parentheses if it comes with it. If it was subtraction, that's a little bit different. We'll be covering that in just a second. But with addition, really all you have to do is combine like terms. So I notice I have a constant of 2 here, and I have a constant of -4. So I would combine 2 and -4 to get us -2. From there, I can go ahead and notice I have 3x cubed and a positive 2x cubed. So that would get me a positive 5x cubed. And finally, I have -x squared and positive 7x squared, which is going to get me a positive 6x squared. Now, if something doesn't have a like term, then you just bring it down, okay? But with this particular problem, we had like terms across the board, so we go ahead and combine them. But there's one thing I want to point out here. The form that we're in right now should be a little bit weird looking because we're not in standard form. Remember, standard form is descending order, highest degree to lowest degree. When we're in terms of one variable, highest exponent on x or whatever your variable is to the lowest exponent on whatever your variable is. So I should actually not leave my final answer like this. I should rewrite this in standard form, which would be 5x cubed plus 6x squared minus 2. And that would be our final answer. And as we can see, what we're dealing with here actually is a cubic trinomial. If we wanted to classify this based off the degree and the number of terms, we could say that this is a cubic trinomial. Now, what if we had a subtraction problem, something like this? And notice I am going to have this in descending order from the get-go. That way we don't have to worry about it. But you should never assume, and you should always double check to make sure your answer is in standard form, which remember is descending order. So if we have subtraction here, what we want to do is make sure that we distribute that negative to everything in that second polynomial, okay? Now, you can drop the parentheses once you distribute. If you wanted to, you really could go 4x to the fourth minus 5x to the fourth, combine like terms that way. However, mistakes could be made when you're dealing with double negatives, so I prefer to distribute everything. So I'm going to bring down everything in my first polynomial here because this one did not have a negative out in front of it. So none of these terms are going to change just yet. So I'm going to bring down all of these. And then I'm going to distribute this minus, this negative, to everything in this polynomial because we are subtracting this polynomial, so we need to switch the sign. So this is going to now be -5x to the fourth, positive 2x cubed, -4x, and -9. And from here, we can go ahead and combine like terms. So I have 4x to the fourth and -5x to the fourth. So when I combine those, that's going to get me a -1x to the fourth. From there, I have -3x cubed and positive 2x cubed, which is going to get me a -1x cubed. From here, I have a positive 2x and a -4x, so that's going to be a -2x. And from there, I have -7 and -9, which is going to get me -16. So this is a very negative polynomial, okay? But if we notice, this is already in descending order, hence standard form, so this would be our final answer. So -x to the fourth minus x cubed minus 2x minus 16 would be our final answer. It is okay to have a negative leading term if we're not factoring. If we were factoring, we want to factor out at least a -1, but we're just simplifying, we're just subtracting these polynomials, so this is a perfectly acceptable answer. So let's go ahead and quickly talk about multiplying polynomials, something that we've actually already done before. So we've seen problems like these before where we have two binomials multiplying each other. Remember, binomials are polynomials, so this is technically multiplying polynomials. We've seen these problems before where we have to distribute the first term to everything in the second polynomial, which would get us 2x squared minus 6x, and then we distribute everything, or the 1 to everything in the second polynomial, which would get us a positive x and a negative 3. And then we would have to combine like terms. In this case, it would be negative 6x and positive x to get us our final answer of 2x squared minus 5x minus 3. You've done this plenty of times. You probably refer to this as FOIL. This is multiplying polynomials. But what you might not have covered as much is multiplying something like this. Well, when we multiply polynomials, we're applying that same idea over and over again. We're just distributing everything from the first polynomial into everything from the second polynomial. So I would apply that exact same logic. So I would distribute the 2x to the x squared, to the negative 3x, and the positive 4. So that would get me 2x cubed now, minus 6x squared, plus 8x. And then I would distribute the 1 to everything in that second polynomial. So 1 times x squared will get me x squared minus 3x plus 4. And now, once again, we have like terms to combine. We do not have a like term for x cubed. 2x cubed is the only one of its kind, so we just bring it down. We do have like terms. We have negative 6x squared and positive 1x squared, so we would combine those to get negative 5x squared. We also have like terms with linear, okay? So we have an 8x and a negative 3x. That's going to get us a positive 5x. And then we do not have another like term for our constant of 4, so we just bring that down. And this would end up being our final answer. And once again, notice that this is in standard form. It is in descending order. Highest exponent on x to lowest exponent on x. So as we can see, multiplying polynomials, regardless if it's a binomial times a binomial or times a trinomial, we can even have a trinomial times a trinomial. The same steps apply. Take everything from your first polynomial, multiplying into everything in your second polynomial, combine like terms. That's all that it is. So I hope this video was helpful. If there's any questions, please feel free to let me know. We will be talking about division in a future video, probably 2 of them, just because it can be a little bit difficult at first. And especially because it is so important once we get to finding zeros of polynomials. We'll be covering something called the rational root theorem, where it comes in very, very handy. So if there's questions, please feel free to let me know. Otherwise, I look forward to seeing you guys in that next video.